Java to JavaScript lesson number 9, Refactor and Reuse. In the previous tutorial, we defined two new custom asynchronous modules. The first one is to calculate the area of a circle, and the second one is to calculate the area of a square. In this tutorial, we are going to talk about some software engineering practices by using RequireJS. The very first thing that we are going to talk about is software refactoring. Software refactoring is coined by Martin Fowler in his Refactoring book. For details, you can go to his refactoring.com website. In terms of definition that is provided by Martin Fowler, it is a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. It is to restructure software by applying a series of refactoring without changing its observable behavior. And we'll demonstrate how we can use RequireJS in order to do that. The second software engineering practice that we are going to demonstrate with RequireJS is software reuse. The whole point of software reuse is to avoid reinventing the wheel. For example, all those libraries and templates that we reuse from some other developers or open source libraries are ways of reusing software components and views such that we don't need to rebuild it. In this tutorial, we are going to demonstrate the technique of refactoring in RequireJS. We are going to refactor specialized modules to a more generalized module. We define a module to calculate the area of a circle. Now, circle is actually a specialized version of an ellipse. So by refactoring the area of the circle formula or module into the area of ellipse, we provide a more general modules in terms of the calculation of both area of circle and area of ellipse. Similarly, the formula for calculating the area of a square is a specialized version of the formula of calculating the area of a rectangle. So we'll perform this refactoring as well. The third one that we are going to do is to refactor the area of a rectangle, which in this particular case is a specialized one, to an area of parallelogram. In terms of demonstrating software reuse, we are going to reuse some generalized modules for specialized modules. Let's take a look at the example. An area of a triangle is actually half of the area of a parallelogram. So we'll reuse the area of parallelogram and divide it by 2, and we got the area of triangle. Similarly, area of trapezoid is equal to the area of a parallelogram divided by 2 as well. So we'll reuse that. So the area of sector is depending on the theta angle. So in this particular case, we have a ratio of theta divided by 2 pi, which is 360 degrees in radian. Let's get to the code. So last week we have the module for calculating the area of circle and the module for calculating the area of a square. Let's bring up all the formulas. So last week we have done this, the square, and the circle. We have these two modules. And this week we are going to refactor the circle and the square to become calculating the area of rectangle, parallelogram, and ellipse. Okay, so let's do that. Alright, so before we do anything, again, as usual, we'll start up the server. So npm run dev. Okay, the server is started up. Everything's working so far. Alright. Let's take a look at the browser debugger. So we have the area of square is equal to 4 and area of circle is equal to 12.56. Let's take a look at the main.js. In the main.js, we have square of a 2 is a 4, and the area of a circle with a radius of 2 is equal to 12.56. All right. So let's refactor the circle.js. By doing that, let's create a module for ellipses. So new file, ellipse.js. Okay. Since we are kind of refactoring this, let's copy the content of the circle, put it into the ellipse. Again, we use the RequireJS defined to load in the constant for the pi, because area of ellipses is equals to pi times axis A times axis B. Let's take a look at the diagram. So ellipse, the area of ellipse is equal to pi times A times B. Okay. So this is what we got right here. Let's change this as well. So we have A and we have a B. And then we change this to A comma B. So we have the ellipse, the area of ellipse formula. Let's go to the main.js and add this. Alright, so variable area of ellipse equals to ellipse A and B. Let's make it 2 and 3. Console.log area of ellipse equals to area of ellipse. Okay. Let's save it, but it won't work for now because we haven't loaded the ellipse calculation. Let's take a look at that. So now ellipse is not defined because we haven't loaded the module. So let's load it. Alright, so let's load in the ellipse right here. Okay, and remember the order of these guys are important. So 1, 2, 3, 4, 5. The fifth one is ellipse. 1, 2, 3, 4, 5. So it must be here. Alright, and we can remove this constant because it doesn't mean anything. We haven't loaded anything for constant. And this should work. So the area of ellipse is 18.84. Alright. So we have a module for calculating the area of ellipse. However, we haven't refactored the circle formula to use ellipse. So let's do that. Okay, so in here, let's remember that is 12.56 with the original formula. So let's do that. Let's make the change right here. It's equals to, well, it's the same thing there, but this time we need the ellipse. Okay. And let's use ellipse as well. What we are doing right here is we'll take out the original formula, but we calculate using ellipse, radius, and radius. Let's save that. Okay, let's take a look at the calculations. It works because it has the same value. Alright. However, we are actually using ellipse formula to calculate the area of the circle. So we have done one refactoring. Let's close that. Now let's work on the area of the rectangle and the square. So let's create a new file, rectangle.js. Alright, let's copy this, put it into the rectangle, and area of rectangle equals to, let's take a look at the formula again. So the area of the rectangle equals to the width times the height. So let's make it width times height. Alright, so we have width, height, and the calculation is width times height. Alright, let's save it. Let's go to main.js. Include the rectangle and the rectangle formula. And then var area of rectangle equals to rectangle. Let's use 2 and 3 again. And console.log. Let's print it out. Area of rectangle equals to area of rectangle. Okay, let's save it again. And the area of rectangle is 6. 2 times 3 is 6. So that's correct. Now let's refactor the square. So in here we have let's load in rectangle. Okay, rectangle, and then let's return rectangle, and we put in the side. Square has only one side length, but rectangle has 2, which is the width and the height. Okay, so let's go back to the main.js, and we are reusing the rectangle function, right, in the square.js. So let's take a look at the square one, the square answer. And the square answer is 4, which is correct. So that's how we refactor the square module by reusing rectangle. Another one is parallelogram. So let's create a JavaScript file, parallelogram.js, and again, it is actually a refactoring of a rectangle. So these two are very much related. The only difference is 90 degrees right here, but this one doesn't have a 90 degrees. But it's still base times height. And in the rectangle case is like width times height. Okay, so let's copy the rectangle, change it to parallelogram, and it's base times height. So base times height and base times height. All right. Let's go to rectangle. So in this particular case, rectangle depends on parallelogram. And parallelogram. All right. And the function equals to parallelogram width, which becomes the base, and the height stays the same. Okay, let's save it. And one more thing, we need to display the area of parallelogram. So area of parallelogram equals to parallelogram, say 2, 3. Okay. At this point, let's load in the module. Okay. Let's display that on the screen. Area of parallelogram. Okay, let's save it. And the area of parallelogram is 6. All right. And at this point, the rectangle is reusing, or yeah, it's kind of reusing the parallelogram module. Since the formal parameters of calculating the area of the rectangle is width times height, and the formula for calculating parallelogram's area is base times height, and because we have 2 parameters versus 2 parameters, we could take a shortcut by returning the parallelogram function directly. So what we can do is take this out, take that out, take that out as well, and then just return the parallelogram function, and it should still works. Let's take a look at the result. So the area of rectangle is 6. Let's build something that reuse the parallelogram module. So in this particular case, a triangle is actually half of the base times height, which is, if you draw a line right here, and that would be a triangle. So it's half of the area of the parallelogram. All right, so let's create a new file, triangle.js. Take a look at this. This time, let's take a look at the rectangle one, because rectangle is actually reusing parallelogram. So let's copy this to the triangle. Area of triangle equals to base times height divided by 2. So what we got here is divided by 2. And let's put in base. Okay. Save it. Let's go to the main function, the main module. Var area of triangle goes to triangle 2, 3. And we got a loading triangle right here. Triangle. Okay. Let's copy that, paste it here. Area of triangle goes to triangle. Save. And the area of triangle is 3. We use the same base and height of this parallelogram in the triangle. So 6 divided by 2 is 3. So that's correct. Let's build a trapezoid. Trapezoid.js. Okay, so again, the trapezoid.js is reusing parallelogram. So in here, what we have is the half of A plus B, the top and the bottom, which is the base. The addition of these two divided by 2 times the height. So the trapezoid is again half of the parallelogram, but it is just that we take kind of like an average of the top and the base. And in this particular case, trapezoid is kind of like the triangle which we use parallelogram. So let's go to the triangle, copy, go to trapezoid, paste, area of trapezoid is the top plus the base times the height divided by 2. Okay, so in here we need to put the top. So top, base, and height. So what we got here is the top plus the base, okay, times the height divided by 2. Alright, so let's save it. Go to the main. Area of trapezoid goes to trapezoid. Oops. Let's put in trapezoid. All right. Okay. Let's go back down. Copy that. Paste it. So let's make it such that it's a 1 at the top. The top has a length of 1, the bottom has a length of 2, and the height has a length of 3. Let's put a 3 right there. Okay, let's display that on the screen. Trapezoid. That goes here. Save. So the area of the trapezoid is 4.5. Let's take a look. So the top is 1, and the bottom is 2. So 1 plus 2 is 3. 3 times height is 9. 3 times 3, right? So it's 9, and it is trapezoid, so it's divided by 2, so it's 4.5. So the calculation is correct. All right. And the last one is we are reusing circle, the module of the circle, to calculate its sector. All right, so let's new a file, sector.js. Let's take a look at the formula. So the formula is actually half of the R square, the radius square, times theta, where theta is angle in radian. Okay? So since it depends on the circle, let's take a look at this. Let's copy the circle, paste it in the sector. All right. And in this particular case, we need to provide 2 parameters, which is the radius and the angle in radian. So let's do that. Angle. Okay. So since this is a sector, that it is reusing the circle one. So let's load in the circle formula or circle module. And we are calculating a circle based on the circle. But in this particular case, we are going to provide the angle in radian. Okay. So the calculation is half of the radius square times the radian. So we got to divide it by half. So let's think about the formula right here. In effect, what we have is the area of the circle times the ratio. And what is the ratio? The ratio is the angle in radian. Let's make it in radian. In radian. Okay. Divided by 2 pi. So what we got to do is we'll times the ratio. And we need pi in this particular case. So let's load in pi. Okay. And the constants are here at the first one, divided by 2 and divided by constants dot pi. Let's take a look at the constants. So we have pi right here. So that should be correct. Save it. Okay. And let's go back to the main function. Circle has only one input in the formal parameters. So let's take out the second radius right here. Let's save it. Let's go to the browser. And we see we have the correct values right here. We gotta load this module as well. We gotta load this module first. Sector. Okay. Var area of sector equals to sector. So we got to provide two parameters. One is the radius. Let's make it 2. The other one is the angle in radian though. So what we got to do is, say for example, if we would like to have a sector of, say, 90 degrees. Okay. So 90 degrees times 2 pi times 2 times pi. So in this particular case, we need the constant as well. So let's go to the back of it. Okay. All right. Let's go down. Times constant dot pi divided by 360 because that's the ratio. So we could do it like this, and then console.log area of the sector equals to area of the sector. Okay. So the way we calculate this is, say for example, if we would like to have a 90 degrees sector, and since we got to convert this in radian, so what we got to do is times the 2 pi divided by 360. 360 is the degrees, so these two cancel out, and we have the 2 pi divided by 4 is pi by 2. And pi by 2 is 90 degrees. So this conversion is correct. So area of the sector is 3.14. Okay? If you take a look at this, the area of the entire circle with the same radius is like 12.56. And here is 3.14. So 90 degrees is a quarter of a 360 degree circle. All right, so this is correct as well. But we have some kind of formula right here, which is kind of complicated. Can we externalize this? Yes, we can. So let's create a new function, a new file as well. It's called, say, converter.js, converters.js. Okay. Let's define which is a RequireJS thing. Do we have dependency? We do. We need a constants. So let's take constants. And we have a function that loads in the constants. And then in this particular case, we're going to return another function. Okay. Say angle in degrees. Okay. And in this function, we are going to return angle in degrees times the ratio. And the ratio is, for the conversion, is 2 times the constants of pi divided by 360 degrees for the entire circle. So let's save that. Back to the main function. Now let's put in converters. Let's take this out. So we have converters, 90 degrees. Let's save it. We still get the same answer. Okay, say for example, if we would like to change it such that we should be saying converters dot degree to radian. Okay, so let's copy this, go back to the, save it, go back to the converters. So we are returning a function right here, but instead of that, we return a JSON. Okay. And the JSON itself has a key of this, the degree to radian. And let's copy this whole thing there. Cut it, paste it, take out the semicolon. So right now we have a degree to radian converter within the converter. Okay, so let's take a look at the sector thing. main.js. So this should be okay. Let's take a look. So the calculation is there with the correct value. So we have refactored some complex computation that is from here originally to a separate module within the converters. Now our code is much cleaner in terms of no matter whether it's readability or maintainability, and in terms of changing the functionality and so on and so forth, it is much easier and cleaner. So this concludes the RequireJS tutorial with software engineering practice, refactoring, and software reuse. Stay tuned for the next episode for the tutorials. Thank you.